My name is Franci Zajc and I'm a researcher in FRAZA. We develop innovative cutting-edge magnetic component power drivers that strengthens our company commitment to innovation and sustainable technology. And in October of 2022, we were invited to join the EU co-funded project DEEP PPU, working alongside an outstanding consortium of partners. Within the DEEP PPU project, FRAZA developed custom magnetic components within the RFG generator unit and filter unit to ensure the development of the most advanced and optimized systems. Strong collaboration was established among FRAZA, UPM, and Airbus CRISA, with 2 meetings per week held to combine. The process of making the best possible magnetics components was performed in 4 steps. Once the state of art was analyzed, in our knowledge, the best solution for magnetic components was chosen, and the magnetic components were designed to reach as minimal possible volume, mass, and losses as we could achieve. The magnetic components were further on manufactured and tested and later sent to UPM for further testing within the actual system. Finally, the designs were adapted to be space qualification eligible. And throughout the initial state of the art review, we were analyzing not just the products on the market, but especially physical background of the process that happened in the given operating conditions. Our goal was to achieve high current carrying capacity at high frequencies. We tried to minimize the high frequency effects, and we tendency to eliminate longitudinal current, and we tried to shape the products in a shape that was cooling friendly, and accordingly the most suitable technology was chosen. And the UPM did a great work on researching for the best electronics option. They came out with a variety of possibilities for the electronics. For each and every option, magnetics were calculated and simulated in order to evaluate whether the architecture is suitable. And as we were given the input data for the magnetic components, we would then calculate an optimal magnetic design regarding volume, mass, and losses based on chosen technology, and then give them the feedback for the final system loss and volume evaluation. And once the optimal design combination was mutually chosen, we developed custom production tools for each magnetic design, produced and then tested, measured the prototypes we made. And here are the 7 prototypes we developed, namely isolation transformer, zero voltage switching inductor, buck inductor, zero current detection sensor, and compensation network inductor, filter inductor, and we also made a linear conductor magnetics. As said, all magnetic components were designed considering space demands, and all magnetics is done in a way so that it can comply with military standard 981. And also the production process was simplified during the various prototypes that we made. The magnetic components presumably showed over 90% reduction in volume and mass. Also, about 90% loss reduction, and possibly we are estimating to achieve 50% cost reduction, and those estimations were done during our market, well, actually available space certificated magnetics in the market that we found. And additionally, the collaboration in the DEEP PPU project also resulted in FRAZA developing new ways to use our own technology. Current detection sensor with extremely quick responsiveness was developed. The latency of the sensor is as low as 9 nanoseconds. And while the volume and losses staying considerably low. Additionally, we solved the issue of longitudinal current in linear structures built with parallel flat conductors. We produced a 6-meter long conductor just to confirm the hypothesis. And in the collaboration in the EU co-funded project, DEEP PPU had an immense impact for our small company. We made many technological improvements, and the FRAZA magnetics technology was introduced to zero current detection and linear conductor technology. The industrialization process was improved. Adaptation for space applications were made. Besides to the market recognition and publicity, our EU network of the company has strengthened. Due to technology maturation during the DEEP PPU project, our technology is spilling over to space applications, automotive applications, and industrial drives in high-efficiency power electronics. This cross-sector expansion supports global decarbonization and resource efficiency objectives, somehow reinforcing FRAZA's commitment to sustainable and forward-looking innovation. And really, we are proud and grateful for able to collaborate in this project alongside with quite amazing team. And this concludes the presentation. Thank you really for the attention.